My name is Rod Castillo, a security engineer at Motive Technologies. I'm here with my manager, Pankosh. We're going to talk to you about unlocking the power of data in order to build a robust security program. Data-driven security is the process of collecting and leveraging data to respond, react, and report, and ultimately improve your cyber defenses.
Hello everyone, I am Pankaj. Before we jump into the presentation, I just want to take a moment and talk about what our company does. At Motive, we connect the fleet and automate operations for the companies of physical economy. We have more than 120,000 companies that use our product to enhance safety, productivity, and profitability of their operations. When we talk about impact, apart from operational efficiencies, we have helped our customers to reduce 22% of their road accidents. And that's a really big number, and I'm really proud about that. Now let's talk about security program at Motive. Until 2 years ago, security was done by our platform team, and honestly the team did a great job. But as the company grew, there was a need to have a dedicated security team to ensure data security and privacy for our customers. So we started building out a new security engineering team and formal security and compliance program at the company. In the first year, we focused on visibility, which forced us to implement a lot of scanning tools in our environment. And these tools surfaced vulnerabilities in our code base, third-party libraries, our infrastructure, along with misconfigurations and compliance violations in our environment. After first year, we realized that we have all these tools scanning our environment, but we are still not able to digest the output from these tools in a sensible way, and the insights were not actionable at all. Then we started digging deep to understand what the real challenges are for which we should be solving for. So the first challenge was tool fatigue. It was becoming very difficult for everyone on the team to learn and master these new tools, which ultimately was leading to inefficiencies within the team. None of these scanning tools worked out of the box for us. To utilize each tool effectively, integrations with different system tools, security tools, identity systems, ticketing systems, alerting systems was necessary. And integrating all these tools with one another was taking significant amount of time and effort. The next challenge was manual data aggregation and correlation for reporting. When we built out our security tools, we started reporting on key metrics on regular basis, metrics for vulnerability management, for security incident management, and things like that. We found that we were spending too much time and effort in pulling all this data together and putting that into a presentable format. Then the next challenge was identifying high risk areas. Our engineers' time is very precious resource, and we wanted to make sure that our engineers are spending their time on the most important things for the business. So when we implemented our vulnerability scanning in our environment, we identified hundreds of new vulnerabilities, and we didn't want to throw these hundreds of new vulnerabilities to our developers for remediation. So we started doing manual triaging to assess the real risk of these vulnerabilities based on the systems, the data that is stored or processed on the systems, or the blast radius of these systems. We realized that severity of many of these high and critical vulnerabilities was downgraded to medium or even low, and a lot of the vulnerabilities were mostly false positives. So we realized that prioritization of remediation tasks based on the output from these tools was not a good idea, because the severity rating of these tools didn't really represent the accurate risk that it was posing to our environment. The next challenge was project prioritization. While doing day-to-day work, we often came across gaps in our environment while doing architecture reviews, investigating security incidents, or remediating any vulnerabilities. And we generally add these gaps to our gap register, which is basically nothing but a list of projects in our backlog. However, during project planning, we lacked the key information such as number of occurrences of each gap, or which applications has these gaps. Are these applications internal or external, or do these application like store or process sensitive data, confidential data or not? And at the end, without all this data, it was very difficult to put a risk rating on a gap. Therefore, we were not able to prioritize our projects just based on this, which we really wanted to do, but we took our best guesses. Then the last challenge was measuring ROI. Being a data focused company, after completing our projects, we aim to measure ROI to make sure that we are making the right investments. For example, when we implement a new security tool, we want to assess its impact on our developers' productivity and overall security posture. So we were aggregating all of this data manually, which was very time consuming and laborious and was not fun. So after understanding all these challenges, it was clear that the core problem was twofold. One, the lack of centralized data. Second was unavailability of analytics capabilities for the team to obtain the answers to their day-to-day questions. So as a solution, we decided to build a data-driven security program that focuses on innovation and building an integrated data platform that enables engineers on the team to achieve security and compliance at scale. So now let's take a look at what this platform will do for you. What kind of questions this platform should answer for you. So you want to get answers for understanding what assets you have. So questions like, are these assets internal or external? Who owns these assets? What is running on these assets? Are these assets storing or processing confidential information or not? And things like that. The second set of questions is around what's happening in your environment. Who is accessing your systems? What commands people are running on your systems? What processes are running on your systems, etc. The next set of questions is around what gaps you have in your environment. So things like what vulnerabilities exist in your environment, what resources are not configured properly in your environment, what resources are not compliant in your environment, etc. Then the next one is very important. Understanding what to fix first. You have thousands of vulnerabilities in your environment, compliance violations, misconfigurations, and etc. How do you prioritize what possess highest risk to your environment so that you can prioritize what to fix first? The next question is around who will fix it. Generally, teams spend good amount of time in triaging security issues and manually figuring out who will fix a particular vulnerability or a compliance violation. You want this platform to give you answers to these questions so that all of this can be automated. And the last one is around ROI. So let's say you roll out a new security scanner for developers. You want this platform to tell you how many developers are using it, how many teams are using it, has it resulted in reducing the number of security defects going into your production environment. Now, let's take a look on how we would build such a platform. So the first thing you need is data sources. You need to integrate your data sources and insert all the data into your data lake. And then all of that information will be processed by your correlation engine and analytics engine and rule engine. And then the outputs will go to the alerting platform and ticketing platform. So let's talk about the data sources. So you need user logs, which will help you understand your internal users and which teams they belong to. You need system logs to understand what processes and commands are running on your systems. You need asset inventory to understand what assets you have, what data is stored on those assets, who owns them. You also need application inventory to understand what kind of applications you have. Are these internal, external, who owns these applications? You need vulnerability scanning data. This will help you understand what kind of vulnerabilities you have in your environment across your code base, third-party libraries, container images, cloud environment, etc. You need CSPM data to understand or to query the list of resources that are not compliant or the resources that are not configured properly. And then you have ETL. These are basically custom scripts which will help you do advanced correlation and push your data to data lake. So data lake is the central database where you store everything, and data analytics helps you build or understand the trends on how things are getting better or worse in your environment in different areas of security. This information is also vital for planning your roadmap, demonstrating ROI, and making data-driven decisions. The next component you have is rule engine, which will help you write detection rules on top of data stored in data lake to generate the security alerts. The alerting platform basically automates sending out the alerts via Slack, email, or whatever communication channel you use. It's very important to integrate your rule engine and data analytics engine with your alerting platform so that alerting can be automated, and also with the ticketing platform so that you can automatically assign tasks to different teams for remediation of security risk. Now that we have seen how to build a data-driven security platform, I will hand it off to Rod for a quick demo. Thank you.
And before I go into a illustrative discussion about how to put data-driven security in action, I just want to say that we're in our first year as an Elastic customer at Motive, and we've learned quite a bit. And the process of creating a data-driven security organization using Elastic tools is a journey. And what I'm going to talk to you about is something that we're striving for. And again, this is just an illustrated example of a fictitious cloud-native AWS organization. And I'm just going to talk through two use cases that will hopefully be somewhat represented by the screenshot. Now, use case one, if we strive to capture developer team SAST usage and vulnerability data, we're able to show that if you use a SAST tool prior to going to production, you should have fewer vulnerabilities going to production. So that was sort of the idea behind that. Now, again, this is a purely illustrative example. And on the left here, what we tried to show was, okay, how many times, if we capture SAST usage in Elastic as events by team, which teams are using SAST before they launch or they push their code to production? So here in this example, we have the SRE team. And then on the right-hand side, we would have the number of vulnerabilities by server. Now, again, this is just purely illustrative. The idea would be to be able to show somebody in one picture that, okay, this team, SRE, uses SaaS tools quite a bit. And if we were to have a mapping here or some other key here to show what servers belong to what teams, we have two servers here, but none of the servers that have vulnerabilities belong to the SRE team. That would be kind of how I would phrase it. Okay, so it's bringing together this concept of, hey, we can track when SaaS is used, what teams they're tied to, and then what servers are vulnerable and what are they vulnerable with. Okay, so scenario 2 or use case 2 is kind of the other end of that, or the follow-up situation where now I've identified vulnerabilities. If I have server data, and that server data includes not only metadata about the server, but data classification and criticality, we can use a picture, or at least a combination of information to prioritize how we would fix or address vulnerabilities. So if we had our servers and the number of vulnerabilities listed here in this widget, let's say we had 2 servers and we're comparing them. One, if we drilled into this server and we looked at its vulnerability, maybe the vulnerability is critical, and we compare that against, or let's say, I take that back. So this server here, trugr.de, it has a medium vulnerability, and then we look at its classification or its characterization within the business or the IT context, and we see that it has a high criticality and it stores, processes, or transmits data that is confidential. That medium vulnerability, it may get prioritized higher than another server with a critical vulnerability. So if this picture showed that, okay, this is a critical and this is a medium, but if we look at the characterization of this server, job.de, it's really not a very critical server, or the applications or what's stored on there is not really critical, and its data classification is public. So if it were to get compromised, then our business wouldn't be necessarily impacted, nor would the impact of the data, if it were to be compromised or its integrity tampered with, it wouldn't be very high. So using this data and pulling it together for this example was all done using Elastic and open source tools. So again, this is a completely fictitious example, and it was just used to show kind of where we're going and how we see some of the potential capabilities of Elastic and how it could be used in our organization going forward. We do have a number of open source tools we use, and we are using the data that we gather from these open source tools and Elastic to put together a picture for an IT audience, a business audience, to help drive decisions. Our view is we really don't need advanced data manipulation tools and skills to assess, organize, and analyze security data. You can, as I said before, you can use a mix of Elastic and open source tools to do your security management, your detection engineering. While this is the end of our presentation, we are continuing our detection engineering evolution with Elastic. And if you have any questions, feel free to contact us and check out my GitHub profile. Thank you.